Okay, so for this problem we have a rock which is dropped from a window and it falls to the ground. And the word dropped is an important word because it tells us that the initial velocity is 0 meters per second. So it starts from rest. And then, as it falls, it accelerates towards the earth and eventually hits the ground. And because gravity is doing the acceleration, we always know the acceleration is negative 9.81 meters per second squared. The window is 35 meters high, so it starts here and falls to the ground. Generally, we call the ground 0, and so if it starts at 35 meters and it goes to 0, the displacement is negative 35 meters. So it's important that we get that negative there because the rock actually fell downwards 35 meters. And we are asked to find the time. How long is it in the air? How long does it take to fall? So the easiest way to solve this is to use the equation delta y equals v naught times t plus 1/2 the acceleration times the time squared. And what I'm going to do is I'm going to solve this equation for t. So you can see I've got a diagram. Here's my variable list. Here is my plan. I'm going to solve this equation for t. Since the initial velocity is 0, this term disappears, and I want to solve what's left for t. So I'm going to get delta y equals 1/2 a times t squared. Multiply both sides by 2, and that cancels. Divide both sides by a, and that cancels, and we get t squared as this. Or if we want just t, I'll take the square root. So I get the solution t equals 2 delta y over a square root, which when I plug in my numbers, that's 2 times negative 35 meters divided by negative 9.81 meters per second squared. And I'm going to take the square root of all that. And it's important that this negative 35 cancel the negative 9.81 because you can't have a negative under a radical. Plug in your numbers and you'll get a time of 2.67 seconds. So that's how long it takes the rock to fall all the way down to the ground. Question B says how fast is it going? So in this case we just want to find the final velocity. How fast is it going right when it reaches the ground? So in that case I'll probably just evaluate the expression the final velocity equals the initial velocity plus the acceleration times the time. Since I know all those, that's going to be 0. So I just have the acceleration, negative 9.81 meters per second squared, times the time, which is 2.67 seconds, and that gives me an answer around 26 meters per second, and it is negative, and that's the final velocity. That's the velocity of the rock as it begins to hit the ground. So that's an example of how to solve a problem using kinematics, these equations we've developed over the last couple of weeks, and applying it to FreeFall. And the special thing about FreeFall is you already know the acceleration due to gravity. It's always negative 9.81. Alright, so for this problem, a student drops a rock over the edge of a canyon. The rock falls all the way to the bottom, and they see it hit the ground 3.6 seconds later. So the time that it is falling is 3.6 seconds. That part's pretty easy. And we know that because gravity is doing the accelerating, the acceleration is negative 9.81 meters per second squared. We don't really know how fast the rock was moving as it got to the bottom, so we don't know the final velocity. But we do know the initial velocity. We are told the student drops the rock, so the initial velocity is 0 meters per second. And we are asked how high is the student above the floor of the canyon. So we want to know how far did the rock fall. So that's what we're after. So the easiest way to solve this is to evaluate the expression delta y equals v0 times t plus 1/2 a t squared. It's already solved for delta y, so I don't need to solve anything. I'm just going to evaluate it. Since the initial velocity is 0, the distance it falls, delta y, equals 1/2 of a times t squared which I can evaluate by plugging in the numbers. Negative 9.81 meters per second squared times a time of 3.6 seconds. Square it. We'll grab our calculators and quickly compute that value. So I'm just going to take 0.5 times negative 9.81 times 3.6 squared, and that gives me a result of negative 63.5 or negative 64. So that's negative 64 meters. Now remember, this is delta y. This is the displacement of the rock. So if the rock falls 64 meters, how high is the student above the canyon floor? We can do this. We can say that delta y actually equals the final position, which is 0, minus the initial position, y initial. So if I want to know what is y initial, it's negative delta y, or positive 64 meters. So the student starts off 64 meters above the bottom of the canyon when they drop the stone. So here we have a complete solution. I've got a diagram, a variable list, I've got a plan. I solve my plan algebraically. I plug in my numbers and evaluate it. I think about significant figures. Meters is the correct unit, and it's a reasonable answer, 64 meters. Okay, here we go with example number 3. For example number 3, we have a tennis ball which is struck, and it goes upwards, up into the air, and eventually it stops and turns around and comes back down and goes to the ground. And I am asked, how high will it go? So what I got to do is figure out what is special about this point right here, this tippy top point. That's the maximum height, and I got to figure out what's going on there. So the clue here is, if you want to find the maximum height, you got to figure out how high it is when the velocity right there is 0, because the velocity is positive as it goes up. When it reaches its maximum height, its velocity is 0, and then its velocity becomes negative. So we're going to let the final velocity equal 0, and we're going to figure out how high it went up and then solve for y final. So our variable list looks like this. The initial velocity, in this case, is 15 meters per second upwards. So I'm going to put 15 meters per second. The final velocity is 0, not because it hits the ground, but because at the tippy top, it stops moving. The acceleration, of course, is negative 9.81 meters per second squared, because gravity is what's changing the velocity. The time we do not know, and the other thing is delta y, how high it goes. So we don't know that either. And that's actually what we want to find. We want to find delta y. So our solution is going to look like this. First of all, we're going to take delta y. We got to find delta y using the equation v final squared equals v initial squared plus 2 times a times delta y. Okay, so when I do that, my final velocity is 0. So I'll get negative the initial velocity squared equals 2a delta y, or delta y equals negative the initial velocity squared divided by 2 times the acceleration. That's going to be negative 15 meters per second squared divided by 2 times negative 9.81 meters per second squared. And when you plug in the numbers there, you get 11.4 meters. But here's the thing. 11.4 meters tells you how far it moved from here to here, how much it went up. It went up 11.4. But how high is it? What is y final? Well, we know that delta y equals y final minus y initial. So if I want y final, the final height, I've got to take delta y plus y initial. So y final, which is the maximum height, is delta y plus y initial, which is 11.4 meters. That's how much it went up, plus where it started, which was 20 meters above the ground. So it started 20 meters above the ground. So sometimes it's helpful to put that in a variable list. Y initial was 20 meters. That's where it started. And then, of course, we get an answer of 31.4 meters is the maximum height of the tennis ball. Okay, now part B of this says, how long was it in the air? So to solve this problem, we're going to figure out how long it's in the air. So I'm going to make a new variable list. The initial velocity is still 15 meters per second. The final velocity is unknown because we are not ending the problem at the tippy top of the arc. We're ending it back on the ground. In this case, delta y, if it starts at 20 and it ends at 0 down here, delta y is actually negative 20. So this is going to be negative 20 meters. The acceleration, of course, is negative 9.81 meters per second squared. And we are trying to find t. So to do this, we are going to have to solve delta y equals v0t plus 1/2 at squared. We're going to have to solve that for t. So I'm going to put in my numbers. Delta y is negative 20 equals v0 is 15 times t plus 1/2 of a is negative 4.905. That's 1/2 of a t squared. And so what you will have to do to solve this problem is bring 20 to the other side. So 0 equals 20 plus 15t minus 4.905 t squared. And you're going to have to solve it using the quadratic equation. So if you remember the quadratic equation, this coefficient here is c, this coefficient is b, and this coefficient right here is a. And to get your solution, you're going to have to use t equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And when you do that, and we plug in all these numbers, 15 for b, a is negative 4.905, c is 20, you're going to get an answer of about 4.05 seconds. That's how long the ball is in the air.